Hey guys, I have your notes here for section 6.1. So we're going to start a new chapter, and the first two sections of this chapter, we're still going to be using trigonometry. We're still going to find missing pieces of a triangle, kind of like you would have done in the last chapter, like use Pythagorean theorem to find this side, or use trig to find this side length, or whatever, except in this section, in these two sections, we're not dealing with right triangles. So we are not allowed to use Pythagorean theorem. We're not allowed to use straight up trig like you're used to, like opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. We're not allowed to do that because we don't have right triangles this time. So take a minute. You might want to pause down the video, copy down the little bit that I have written here, and then I'll get started. So today I'm going to show you law of sines. Tomorrow I'll show you law of cosines. It's kind of a trade-off. The math for law of sines is probably easier than the math for law of cosines. However, there is a situation when using law of sines that you have to be super careful of, and it's going to require some extra work on your part. Not every time. There's only a certain situation that you got to be aware of that's going to require extra work on your part. That's the disadvantage to law of sines. There really is no disadvantage to law of cosines, except the math is just a little bit harder. But I like law of cosines because it works every single time. You don't even really have to use your brain. You just do the formula, get the answer, no brain activity involved. There is brain activity with law of sines. So let's get started. Before we get started on the math portion, I want to kind of go back to geometry. When you were in geometry and you needed to draw a triangle, and your geometry teacher said, draw triangle ABC. Well, here's what you did. You used a big A to represent an angle in the triangle. You used little a to represent a side length. And we typically draw those across from each other. So I'm going to go over here to my triangle. You can start at any vertex that you want. It doesn't matter, okay? So I'm going to start, doesn't matter. I'm going to start here, and I'll go A, and I'll work my way around, capital A, capital B, capital C. There, I've drawn triangle ABC. Now, I need to label the sides. So I'm going to start with big A. I'm not going to do these two. I'm going to go to the side across from it and call that little a. Across from B and call that little b. Across from angle C, and I'm going to call that little c. Capital letters represent angles, lowercase letters represent side lengths, and they correlate. They go across from each other. Now, before we get started, here's big picture, here's overview, here's what we're doing. If I were to give you, I'm going to kind of do this at random. If I were to give you a stick that was 5 inches long and another stick that was 8 inches long, and I were to tell you, take those two sticks, join them at one end, join the two sticks at one end, and position them, like, hey, here's a protractor, by the way. Position them so that they form a 98-degree angle. So you're holding in your hands a stick that's 5, inches long, a stick that's 8 inches long, and you've angled them so that they make a 98-degree angle. Did you know that in order to complete that triangle, because this measurement is fixed, this measurement is fixed, and this measurement is fixed, and by fixed I mean locked in. If somebody were to come along and finish off the triangle that you started, they would be required to have a stick that was 10 inches long, and it would attach to this one right here, it would attach to this one right here, and these angles would automatically have to be 52 degrees and 30 degrees. If you're given these three fixed pieces of information, there is only one specific size triangle you can make. These three fixed pieces couldn't form any other shape, size triangle if this were 8 inches, this were 5 inches, and this were 98 degrees. Your triangle would have to look like this. This side would have to be 10, this would have to be 52, and this would have to be 30. You wouldn't have any other options. That's kind of what we're doing today, is I'm going to give you 3 pieces of information. I'll give you this, this, and this, and I'll say, if those are 3 pieces of information in a triangle, what do the other 3 pieces have to be? What's the missing side length? What's the missing angle? What's the missing angle? Because there are 6 parts to a triangle, right? 3 angles, 3 sides. If I give you those 3, you give me these 3, there are right answers and wrong answers. Like, this is the only right answer for these. It's the only size, shape triangle you could make. And one more thing before we get started. Do you remember these types of problems? We're going to be using this button on your calculator today. So if you remember this, you were usually looking for an angle. You would do this on your calculator or whatever. You were looking for an angle. Did you know that your calculator has its semicircles memorized? So the moment I hit sine inverse on my calculator's like, ooh, I got this. I'm either going to give you an answer in quadrant 1 that's acute and positive angle, or your calculator says, I'm going to give you an answer that's in quadrant 4. It's going to be acute, but it's going to be a negative angle. I'm ready. Let's go. That's what your calculator's saying. The moment you hit this button, it's got these in mind. Whenever you hit this button, your calculator will never give you an answer in quadrant 2 or in quadrant 3. Never. There's nothing you can do to this to make your calculator give you an answer that comes from either of these 2 quadrants. Okay, just kind of keep that up there. We're going to need that later on. So, we've gone over that. Alrighty. Law of sines. Here's the math behind law of sines. Here's what it looks like. It says, don't worry about that. I'll go over that later. Law of sines says you can take a ratio. You can take a fraction. You can take side A and put it over the sine fraction for angle A. And you get a fraction out of it. I don't know. You get like a fraction out of it. Like 4/5 or something yucky. It's a specific fraction. Did you know that fraction will produce the same thing as the fraction if you take side length B and put it over sine of angle B? They create the same fraction. Also, they create the same fraction as if you take the side length for little c and put it over the sine fraction for angle c. They create the same fraction. Oh my gosh, that's kind of freaky. They create the same fractions. Now, this is all true like this. This is all true upside down. So you'll see when I do my math, I like to do all my fractions upside down, and I'll show you that later. Now, if you are a memorizer, you're going to want to memorize these 3 scenarios in which you use law of sines. Now, let me go back to a bigger triangle where I can show you a little more. All right, in geometry, you kind of learn these acronyms like angle, angle, side, side, angle, side, angle, stuff like that. So watch, I'm going to start somewhere, it doesn't matter where. I'm going to start at this angle. Watch if I walk around my triangle. Watch what I encounter. I'm starting in an angle. And here I go. I'm going to start around my angle. I encounter this side. And then I've got this angle. And then I've got this side. And then I've got this angle. And now I've got this side. And now I'm back to this angle. So they alternate. Angle, side, angle, side, back to angle. So if you're given two sides and the angle between them, we would call that side, angle, side. That's the order in which they occur. And it doesn't matter which way you go. You can go this way and you can say, okay, I've been given side, angle, side. So that's not on here. What is on here? I don't have mine memorized. Angle, angle, side, angle, side, angle. Okay. So for law of cosines, let's look at these. Angle, angle, side. So I'm going to pick any two angles. Angle, angle, and a side not between them. So not this one, but this one. Check this out. If I'm given this angle, not that, this angle, and this side length, that would be called angle, angle, side. That's a situation in which I would use law of sines. Another one is angle, side, angle. Let me show you what that would look like. Maybe you would be given this information, angle, side, angle. See how they go in order? An angle, a side between them, and an angle. That's another situation in which we're going to use law of sines. Or, and this last one, this is a tricky one, side, side, angle. Let me show you what it looks like. Two sides, I'll pick any two sides, side and a side, right? Two sides and an angle not between them. Maybe you're given two sides and not the angle between them, some other angle. This is another instance where we're going to use law of sines. So if you're a memorizer, you might want to memorize the 3 times when we'll use law of sines. I'm not a memorizer. I just always look at my triangle and I try it real quick in my head. I'm like, ooh, law of sines would be this, 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 and this. Nope, doesn't work. Also, I'm going to introduce a new area formula to you. And this area formula is really nice because you don't have to know the height. You're used to area equals 1/2 base times height. Well, if you were to use 1/2 base times height in this triangle, you would have to create your own height and you would have to find it. Well, thanks to this area formula, you don't need the height. All you need, think about this, all you need is 2 side lengths. You need 2 side lengths, B and C, and you need the angle that is between them. If you have this much information, you can plug the information into your area formula and you can find the area of the triangle, never having to find the height of the triangle. It's pretty convenient. Okay, so we'll get to that later. Let's do this one. For this example, it says solve the following triangle. You need to know solve the triangle means find all the missing angles and all the missing sides. There should be 6 in total. So look at the information that it gave me. I'm going to go and draw my triangle, and I'm going to call it triangle ABC. You can start anywhere you want. Capital letters. Now, go across and label the sides. Little a, little b, little c. Write down the information that you're given. Angle B is 33 degrees. Angle C is 46 degrees. Little b length is 4. Now, before we get started, is there anything that you can go ahead and be like, oh, I can find this really easily? You can find angle A really easily. All 3 angles of a triangle add to 180. Why don't you go ahead and find angle A? There's only one measure it could possibly be. I don't need trig for that. So 180 minus 33 minus 46, A has got to be 101 degrees, no doubt about it. Didn't need trig for that. There's no other angle it could possibly be. Now, to find, I got 2 more things to find. I need to find these 2 side lengths. So here's what law of sines says. I'm going to make 2 of these fractions at a time. I don't want to make all 3 at a time. I'm just going to make 2 at a time. I can either grab angle A and use its sign and pair it with this, or I can grab B and use its sign and pair it with this. Or I can do these 2. I can grab angle B and pair it, and angle C and pair it. Or I can use these 2. It really doesn't matter. I definitely need a pair of information that definitely goes together. Here's what I mean by that. A pair of information that goes together. Like angle C and little c. Do I know both of those? I don't. Like little a and big A. I don't know both of these. How about big B and little b? Ooh, I know these. I'm going to grab these. I'm going to turn these into one of my law of sines fractions. And then I can find some missing information. So here's how I start. Here's how I started. I said, you know what? And see, this is example. This is how I set my fractions up. I like to put the sine and my big angle on top and my side length on the bottom. That's just me. So I'm going to use, since I know angle B and side length B, I'm going to use this one. And I'm going to end up finding my missing little c. So this is the proportion that I'm using. This is called a proportion. Here I go. Watch me sub in my numbers. So angle B is 33 degrees. Side length B is 4. Set that up. Angle C is 46 degrees. Side length still unknown. Okay? Now, I'm not going to tell you to take out your calculator and calculate these values yet. I want you to go ahead and cross multiply and solve for C. So watch what happens. Watch what happens when I cross multiply. I get C times this equals 4 times this. Wait, don't grab your calculator yet. Divide both sides. If I'm trying to find C, go ahead and divide both sides by sine 33. How do you find C? You do this math on your calculator. Make sure you're in degree mode. 4 times sine of 46, close your parenthesis on your calculator, divided by sine of 33, close, equals. You'll get little c is approximate, we had to round, 5.3. Round on your paper, store in your calculator if you think you're going to need it later. So C is approximately 5.3. So here I go. I'm going to go up here, and I'm going to change colors because in red, that's what I'm finding. How do I say this? The black were facts that I was given. The red are the things that we came up with. So we came up with 101. We came up with the fact that C is 5.3. Now what else do I need? I need a little a. Little a. Little a is going to be paired with this one. Now, do you want to use this information as your other fraction, or do you want to use this information as your other fraction? I would totally go with this one because that's yucky. And if you didn't store it on your calculator, or even if you did, this is going to be easier to go with your B pairing. So I did sine of big B over little b, sine of big A over little a. Cross multiply, divide both sides by sine of 33, and I get little a is approximately 7.2. Little a is approximately 7.2. There we go. I have just solved that triangle. Okay. Law of sines, you're going to use two of your fractions, set up a proportion, cross multiply, find what you need. Alrighty, moving on. Let's use this area formula. Now, good news, bad news. The area formula, the way it's set up, is it's got little b times little c times sine of angle A. Check out this triangle. Do I know little b, little c, and angle A? Do I know little b? Check. Do I know little c? No. Do I know angle A? No. Bummer. Guess we can't do it. We can do it. Here's the thing. It doesn't matter. It doesn't matter what sides and angle you use. So you can use these two sides. Guess which angle you'll use? So every letter is accounted for in this area formula. Whichever angle you have, which in this case, where am I? In this case, I have angle C. Let's use that angle. Let's set up my formula to accommodate angle C. If I set up my formula to accommodate angle C, my other two letters need to be accounted for. Those are my little side lengths, and I have those in my picture. So I simply just set up my formula. Little a was 7, little b was 10. I need to use sine for 25 degrees, according to all the information in the picture. Did the math, 14.8 square units. It's all good. Okay, moving on. This is the last example. I'll try to go quick, but man, this is a toughie. So watch me draw my triangle, and remember, these triangles are not to scale. Like, you're just going to go whoosh. You're going to draw some randomly shaped triangle. You're going to throw an A on it and a B on it and a C on it and they're not to scale. So if this is the way we draw our triangle and it says, okay, now label angle A with 80 degrees. Don't freak out because angle A doesn't look like 80 degrees. It's no big deal. Little a, little b, little c. I'm going to write what I know. Little b is 12.5. Little c is 20.1. Angle B is 37.3. Okay. Watch what I've been given. I have been given a side, another side, so two S's, a side and a side, and an angle. Is the angle between them? Nope. So a side, and an angle. An S, and an A. And this one has asterisks beside it. This is going to be a little challenging. When you're given this setup, it's going to be challenging. Here we go. Where am I? There I am. First of all, when we did a problem like this earlier, it was kind of cool because we were given two angles and we can just, bam, automatically find the measure of the third angle. We can't do that this time. So, we're going to use law of sines. Now, let's see. You need to pick a pair of information that goes together. So I see that I've got angle B and side B. That's good. Okay. And I chose to use those. So I've got sine of angle B over the side B. I decided to find angle C first over 20.1. Little c. Okay, so I set it all up. I do this, I do this. Now, when I'm solving for sine of C. Sine of C is this. Okay, well, at some point, I need to ask you a very important question. I think it's going to be now. Before doing anything else on my calculator, look at this triangle. Remember in geometry how the largest angle, the longest side is across from the largest angle, smallest side is across from the smallest angle. Okay, again, this is not to scale, okay? This is not to scale. So if this is 37 and this is 12 and a half, check out this angle. Drawing not to scale. Could angle C be obtuse? Could angle C be obtuse? Well, I think it could be, because the side across from it's definitely bigger than this one. This one's 37, so I know C has to be bigger than 37. Could it be like 100? Could C be 100 degrees? Yeah, because if this were 100 and this were 37, that would still leave about 40-ish for this one. Yeah, C could be obtuse. Could it be acute? Yep, it could be acute. It would have to be bigger than 37.3, right? Because this side length's bigger. But yeah, it could be acute. It could be like 90 or 80 or 70 or I don't know, 60. Yeah, it could be either acute or obtuse. Remember that. Angle C could be acute or it could be obtuse. Did we have this discussion for this angle back here? No, because I already had these two. There's only one thing this angle could have been. This one's different. This one's different because I was only given one angle and I've got two left. Yeah, angle C could be obtuse or acute. Keep that in your mind. So here we go. We've got our setup over here, sine C. I get this yucky decimal. That's not C. That's your sine fraction for C. Did this math. This is my sine fraction. How do I get my angle if I have my fraction? Yes. So keep that in there. This is yucky. Do sine inverse on your answer. You know where your answer button is? Your answer button is down here above the negative sign. So if you get something yucky and you need to use it the next time around, just do second answer. Sine inverse answer. Make sure you're in degree mode. And it'll tell you 77 degrees. Oh, C is 77 degrees. Does that make sense? Sure it does. I bet you like that answer. It's bigger than 37, which you knew it was going to be. So now are you sitting there thinking, oh, okay, my calculator told me it was 77 degrees, so it's not obtuse. It's 77, because my calculator said so. Remember what button you hit? Remember what button you hit? You hit sine inverse. What's the first thing your calculator thought of the moment you hit sine inverse? The moment you hit sine inverse, your calculator said, oh, hang on, let me get my semicircles ready. and it got its semicircles ready. Since your fraction was positive, your calculator gave you a positive acute angle because your calculator will never, ever, ever, ever give you an angle in quadrant 2 if you typed that in. But you already told me the angle could be obtuse. Your calculator didn't know that. Your calculator will never give you an obtuse angle when you do sine inverse on it, okay? This is where you have to use your brain. Here we go. Brain's activated. Yeah, C could be 77. Or, calculator gave me an acute angle in quadrant 1, but you already told me that the angle could be in quadrant 2. So, yeah, C could be 77 degrees, absolutely. Or, if it's obtuse, you know what your calculator just gave you? Your calculator just gave you a reference angle to use, right? This is either an angle in quadrant 1 or it's a reference angle. So what if 77 were the reference angle for this obtuse angle? What could the angle be? Well, the angle would be 180 back up 77 degrees. C could be 103 degrees. Oh my gosh. But I thought we said it was 77. No, originally you told me it could be either. Originally, way back, you told me, yeah, it could be acute or it could be obtuse. It could be either. So what we're going to end up doing is we don't have, when given the information we were given, we don't have one single triangle answer. We're going to get two separate possibilities. One of our possibilities involves C being 77 degrees. The other possibility involves C being 103 degrees. Two answers. We can go two different directions. Okay, so back up. It's a lot. It's a lot to take in. I get it. Let's go back here. Let's go back to when we thought C had to be 77. Let's finish the problem. Here I go. I put a 77 there, and we just keep on going. So, what would you like to find next? Well, how about we keep the B information. Now let's find, hold on. Now I've got 37.3 and 77. Do your 180 thing and find this one. That would be 65.7. I'll write that in. 65.7, okay. So now I need little a. So here's sine of big B, little b, sine of big A, little a, cross multiply, blah, blah, blah. A is 18.8. That is one possible size, shape, triangle if my original information was this, this, and this. That's one possibility. Okay, so that's one possibility, and I've got it drawn down here on option 1. Now let's back up. How much work had I done when I said we could go two different directions? All I had done was I had found angle A. No, back up. I had found angle C, my bad. I know this work. I found angle C. It was 77. We realized, oh, crap, it could be obtuse. So if C were obtuse, remember, oh, dang it. If C were obtuse, let me show you this again. You might have forgotten it. Yes, my calculator could have given me the positive acute angle, or it could have given me a reference angle for an obtuse. If R is a reference, C would be 103. Okay. If C were 103, then guess what? If this is 103, you know what? That's not 65.7 anymore. I got this after I got this. So if I'm going to say 103 is an option, I have to redo for this math, and I have to redo for this math. And I've got that down here. If C is 103, then this one would have to be 39.7, and I have to do one other proportion, like I have to redo that proportion using this 39.7, finding a new value for little a. Dang, I had to do that problem twice. I mean, it wasn't that much extra work, but I had to do the problem twice. Now, this paragraph explains in words what I just went over with you in the video, but I get two separate answers. So see the black values that are locked in place? That's 20.1 no matter what. I was given that information. That's fixed. 12.5, that's fixed. I was given that information. 37.3, that's fixed. I was given that information. This right here, this angle is where we went two separate directions. Because I found this, where am I? There we go. Because I knew that, then I went and found this. Then I went and found this. Got to do the problem twice. When? When do you have to do the problem twice? Only when you're given information in this order. Right? Think about this. Here, you're given two angles. The third one, easy to find. No weirdness. This situation, you're given two angles. The third one, easy to find. No weirdness. Here, you're given one angle. Uh-oh. What could the other two be? That's when the weirdness happens. Okay, so I'm good. I think I've gone over everything I need to. Good luck.